Okay, let's take a look at number 9 and 10. This is the Unit 11 review. So, let's see, 9, we've got a trapezoid here. And we've learned the area formula for a trapezoid. You could end up chopping this thing up if you wanted to, but let's go ahead and practice using the area formula. So the area of a trapezoid, we know, is 1/2 base 1 plus base 2, which is the average of the bases, times the height of the trapezoid. Well, we've got the two bases, 3 and 10. We just need the height. So let me sketch in the height right here. We'll call it h for height. And notice what we end up with is a 30, 60, 90 triangle because I've got the 90 that I created, the 30 that's there, so this has to be 60. So if I sketch a basic 30, 60, 90 right here, the side opposite the 30 is 1, opposite the 60 is root 3, the other one's 2. So let's see, the 2 goes with the 8, the same way that the 1 goes with the h. So 2 over 8 equals 1 over h. If I cross multiply, 2h equals 8, so h equals 4. So now I know the height is 4, and then I can just plug everything right in. 1/2, 3, plus 10 times the height of 4. Well, I'll switch these around. I'll do half of 4 is 2. So this thing is 2 times 13, which is 26. So the area here is 26. Okay. Number 10 is a bit longer. It actually goes back to the last unit. You would have, everything except for part C, you would have been able to do in the previous unit. So part A says write the equation of the circle. So you might remember, equation of the circle looks like this. X minus h squared plus y minus k squared equals r squared. And we know that h and k are the center point, so this turns into x minus 5 squared plus y minus 2 squared. And the radius we were told is 13, so 13 squared is 169. So I'm going to put that down here. X minus 5 squared plus y minus 2 squared equals 169. Okay. Part B says find the coordinates of where A and B are. And notice that they're where the circle and the y-axis hit each other. Well, anything on the y-axis, the x value is 0. So we know this is going to be 0 comma something and 0 comma something else. So there are a couple different ways we can do it. I'll do them both, but I wouldn't require one over another on a test. You can choose the one that you like. So the first method would be slope triangles and using Pythag. So if we draw in our slope triangles here, and I can draw them to the center point and straight across. Oops, sorry about that. And then straight up and down. So these are right triangles. Now, since I'm going straight across to the axis, I'm going from 0 to 5 here. So this is just 5 units across. I know the radius is 13 from the problem. So I'm going to call the height of the triangle B here. B and B. So 5 squared plus B squared, it's going to be 13 squared. And if you work this out a little bit, you end up with B equals 12. So 12 up, 12 down. So then we can just count over 5 units to the left and 12 up and 12 down from the center point to figure out where we are. Well, 5 units to the left gets me x equals 0. 12 units up from 2 gets me to 14. And 12 units down from 2 gets me to negative 10. So A is going to be at the point 0, 14. And B is going to be at the point 0, negative 10. Which I can copy down here. A is 0, 14. B is 0, negative 10. Okay, let's take a look. Oh, sorry. Let me do another method for this. So some of you, I think, prefer the method that doesn't require you to draw in the shapes themselves, but use the equation that we came up with in part A instead. So if you wanted to do that, you have to know something about the points. And the one thing that we know for sure is because they're on the axis, those x values here are 0. So the second method, use the equation of the circle and the fact that x equals 0 for points A and B. So we'll take the equation and we'll plug in 0 for x. So we get 0 minus 5 squared. And then y is what we're solving for, so we leave the y alone. And negative 5 all squared is 25. And then if I subtract the 25 over, I'll get 144 here. And then when I take the square root, I'm not only going to say 12, I'm going to say plus or minus the square root of 144. Because y minus 2 is not a length, it's coordinate related. So you can't have the negatives now. So it's plus or minus 12. So then y is going to be 2 plus 12 or 2 minus 12. So we get y equals 14 or y equals negative 10. And we knew that happened when x was 0. So a is going to be 0, and it's the higher one, so it's the positive 14, and b is going to be 0 and negative 10. So two different ways to get the same thing. Okay, let me shrink this down a bit, because I'm going to need more space for the rest of it. Oh, did that work? Why isn't this shrinking? Huh, not working. Let me try this. Great. Okay, so it's not working. So I'll write over on the side instead. Okay, let's take a look at C. What does C ask for? C says find the length of the minor arc A to B. Okay, so remember arc length is the angle that it forms divided by 360 times, and then not pi r squared, but it's a fraction of the circle's circumference. So it's the angle of over 360 times the circumference. Okay, so we need to figure out what the angle is. So let me call this thing right here alpha. So this one will also be alpha. So the theta that I'm looking for is really 2 alpha. So we can solve for alpha up here. Why don't we use the 5 and 13? So cosine of alpha is 5 over 13. So alpha is cos inverse of 5 over 13, which comes out to be 67.3801 degrees. So the whole angle, which is 2 alpha degrees, or theta degrees is the way that I referred to it here. So 2 alpha equals theta, which ends up being 134-ish, 0.7602 degrees. So then when I figure out the arc length of AB, I'm going to plug that in, 134.7602 over 360, and then times 2 pi, the radius is 13. And if I work all that out, I end up with about 30.576. So there's my arc length, 30.576. Now if it said what's the measurement of the arc, that would be the 134 degrees. But since it says what's its length, you're actually looking for in how many, something besides degrees there. You're looking for like, well, in this case it's units, but normally it would be like inches, something like that. Okay, and then the last part says find the area of the shaded region. Okay, so the area of the shaded region, one part of it shouldn't be too hard. It's the area of these triangles put together. And then we can add the big Pac-Man shape next to it. So down here, I'll do this. D, area of the shaded, is going to be the area of the triangle, the big triangle that looks kind of like that, plus the area of the Pac-Man shape that fits around the triangle there. So the area of the triangle is 1/2 base times height. And if you think of the whole thing as one big triangle, then this right here is the base, which is 24. And the height is 5 right there, right? So it's going to be 1/2 24 times 5, which will be 60. So that's the area of the triangle. The area of the Pac-Man shape, it's a sector, so it's going to be some angle over 360 times pi r squared. And the angle that we want is this angle. Well, that's 360 minus 2 alpha. And that comes out to be, since we already know what alpha is, or 2 alpha is, then I can subtract that out and I end up with 225.2397 degrees. There'd be some extra rounding involved in there. So that goes here. 225 point, well, what did I just say? 2397. And if you work all that out on the calculator and you cut and paste certain things, then you end up with 332.184. And then the area that's shaded is the sum of this. So the sum equals 392.184. And that's my shaded area. Okay. Hope that helps a bit.